how to configure L3VPN setup with Linux and FRR. So this is the topology. We have a CE node and one more CE node at the other side, and C1 has to ping to the other side CE1. C1 means both are in same VRF domain, and this is the MPLS domain where we have PE1, PE and PE2. So now we will see how to simulate this using a Docker. So in all the previous videos I have mentioned how to create a Docker and install everything. You can check that in case you want. So this is the Docker. This is PE1. This is PE1 node. In PE1 node, from PE1 to PE2, I'm going to create an LSP tunnel first using an LDP. So for that, first we need to create an OSPF. So we'll see how to create an OSPF. And before everything, we have a PE node, right? So in this PE node, I'm going to create a VRF interface to communicate with the other side. So that is the first step we'll do in PE1. This is the command IP link add. This is the VRF name type. This is the VRF name CE1 VRF, and then I'll just set it up and attach it to ETH1. ETH1 is the interface which is connected towards the CE. So come out of this is VTYSH, and this is the Docker, PE1 Docker. To know how to create the Docker and add everything, you can see all my previous videos that has the steps. So I'll just create this. Before giving this, you can give IP link and check. There is no VRF interface. Now with this, I am creating a VRF interface in PE1. So if you see, it is updating the FRR also. So it is created a CE1. So now I will go to the PE2 router, and here also we will create a VRF because that has to communicate to the other side. So I am creating with the same VRF. Make sure you create with the same VRF. That's it. So it has created. This is the first step. Once creating, you have to go to VTYSH and see that it is reflected in the FRR. See, it is reflected in the FRR. So all this route has been moved to VRF route. You can even check the routing table. So this is the normal routing table. This is the VRF routing table. So it has moved here. So this is the first step. And then in PE1, we are going to create an OSPF. And even before that, we have to configure MPLS in host as well as the Docker system. So this is to create in the Docker system, because we are going to send labels. Come out of VTYSH. I am giving this. Third node, and this is the fourth node. And the same configuration has to be given in the MAC ETH also. This interface proc sys net MPLS config. I am just checking whether it is enabled. So it is default enabled. So now we can start in PE1 with OSPF configuration. This is the PE1 configuration. I'll just create a loopback interface with 1.1.1. P6 is not required. And then the next configuration required for OSPF is this. This is the OSPF. Not this VRF. This VRF is for CE. Now I am going to create the tunnel between PE1 and PE2. So only this is enough. And then in PE node, PE1. router OSPF and all the available interfaces, because these are all the connected interface. So I'll explain one configuration. Actually, in the router mode, we have to create an OSPF route ready with the loopback and all the network interfaces and loopback interface I'm connecting in the OSPF. So now OSPF should be up between PE1 and now we'll configure the same in PE2 also. This is the configuration. And OSPF configuration is this. IP OSPF name. So once it is up from PE1, we should be able to reach to PE2 using normal OSPF route, show IP route. So it should be reaching, because 3.3 you can see in the routing table entry. So it is reached. So but this is not sufficient. You have to enable LDP now to send the label. Before that there is no entry. So now I am going to PE1. I am going to configure an LDP. This is PE1. Configuration for LDP is this: conf t MPLS t. You have to give the address family v4, and transport layer is this own self IP, self loopback IP, and ETH2 is the interface on which you need to configure. For example, in this case, loopback only we are going to run, and on ETH2. So that's why I am copying this MPLS LDP address family. Transport protocol is our own loopback IP, and we are going to run in ETH2. So it is ETH2 and exit. So LDP we have configured. It's not up because peer we have not connected. Now PE1 also exactly the same thing, but we have to enable on both ETH1 and ETH2 because we have two interfaces, one towards PE1 and one towards PE2. So this is the configuration in PE route. Now at least LDP should become. So it has started. See one side. Now we have to give L in the PE3 router. So this is the configuration in PE3 router. So center P router should have 2, and then this is 1. So this should create a label. You can see that with show MPLS table. So now we have done with the normal transport protocol. Now if we ping to 3.3.3, it should send with a label. You can go to PE2 and on the receiving interface you can check. Can I ETH1? So if you see it sends with a label putting 17. Why it puts 17 is so MPLS table. So for MPLS LDP it is 17. For 3.3 the label is 17. So that is why it is putting 17 in the label and it is sending. But we need L3VPN now, so we need a BGP also. So initially there is no BGP configuration. Now we will try to configure BGP and check. So for that we will go to same PE1. This normal BGP, this is outer normal BGP. So iBGP I am going to configure. I am going to configure the PE2's neighbor IP is 3.3.3. and I'm going to update the self loopback, and I'm going to activate a VPN with this. So this is the configuration. Only this configuration you need to copy, put it in the first node, PE1. And PE2. Only in PE1 and PE2 we are going to run this, and not in PE3. Sorry, not in PE1. PE1 and PE2 we are going to run, and not in P1. That's all. So we have configured now. You can see the updates also coming. So see, we have got it, but you will not have any VPN paths. So BGP is not there. So BGP IPv4 VPN. This is also not there. So now we have to enable that. So before that, you can see all the routes, whether any update has happened. Nothing has happened because only BGP has come up. Now we have to create an VRF entry. For that, in P1 we have to create this BGP, router BGP with VRF CE1. It is a unicast, and I am going to redistribute all the connected and OSPF routes which I am receiving from CE1, and we have to give the VPN RD/RT values. Both should be this value, whatever you are giving in PE1 should be the same as in PE2. So we will copy this configuration to create a VPN. And in PE2 it's exactly the same thing. Now you can see this BGP has come up. So BGP IPv4 paths. See, path is there now. IPv4. See, it has learned this. So now this is a VRF route, right? So IP route VRF, all you can put, so that you will see that both the tables. If you want to see normally, you have to give the CE1 VRF. So only VRF routes you can check. So now it has learned. It would have put label also for this. It's a CE1 label. Same in third node also. So BGP IPv4 VPN. But now what is the problem is still you cannot ping from CE. We don't have any configurations towards to send the route. So now the next step is we'll do this one. Now we'll go to CE1. In CE1 we have to configure a loopback IP and OSPF, and we'll redistribute all the connected routes in OSPF in PE1. So initially if you see the IP route, we don't have this IP route in CE1 should have the routes of CE2. Then only you will be able to ping. So this is the configuration, and still we have not learned. And then in PE1 we have, this is a VRF interface connected towards CE1. So we need to create VRF OSPF in PE1. So this is the VRF configuration. In that I am going to redistribute all the BGP routes towards the OSPF. So it is redistributed now. this command. The same configuration we are going to do in PE2 and CE2. P1 there is no configuration. P2 we have to give this OSPF VRF and redistribute the BGP routes. This done. And if you go to CE2, you have to configure a loopback IP and redistribute the OSPF, redistribute connected route. Left neighbor, it will take some time to learn the neighbor. Here it would have learned. That 5.5 should learn here. Sorry, 4.4. And this IP route VRF CE1 VRF. Here also we have to get that route. We have to wait for some time. This is the third node. Sorry, IP route VRF CE1 VRF. Now see, it has learnt. So now if you go and see the fourth node, the CE node, it should have the route of the first node. See, it is there now. Now if you ping, it should go with the label. This is 5.5.5. So this is 5.5.5. You go to 0, this is 1.4.4.4. This 4 should learn here. See, now the CE2's route is learned here. Let's start ping to the CE nodes. So ping is working. Now we can try to capture the packet and check. Back 8th one. This is the first interface. This is receive without MPLS because there is the first node. Second node it has to send with the MPLS. You can see it sends with the MPLS, and in the second bridge also it should have MPLS, and in the third one it will not have. This is what I have captured the packet. We can just check that. P node. See, it sends with the 144 label. That's what we saw in this packet also. 144 label. And this is the transport label, which is the LDP's label. So that also you can check. 17. This is LDP's label. Learned through LDP. So inside will be LDP, and then we have outer label will be the L3VPN. So that's why when it goes to PE also it should have the same. So it is 17. And then PE2. It has again 114. So it will pop out this and it will give the packet out. We'll capture the packet. We'll take the Wireshark packet and check once. Captured in the bridge between CE and PE1. Before MPLS route, it is going without the label request as well as the reply. And now it is inside the MPLS cloud. It puts the label. Actually, it puts two labels. One is 17, that is the LDP label. The other one is the VPN label, as we saw. You can see here, this is the VPN label. Learned through BGP. 17 is the LDP label. So this is how it goes in the second bridge. And then when it goes to the third bridge, it will remove the LDP label and it will give only the MPLS label. And the fourth one, it will completely remove and will give the normal. So this is how the packet flows. This is the L3VPN configuration for 5 nodes. So for this, all the Docker, everything is the same, but we have to create one extra Mac VLAN driver than the previous configurations. If you check the previous videos, you can find it. This is the extra configuration which is added here. And the configuration is the same. Docker network plus it will have 1, 2, 3, 4 routers. Sorry, 4 MAC bridge. So you can try this. Thank you.